Alright, problem number 1. The inhabitants of Magrathea use the same mathematical operators that we do, plus, minus, etc. They also use a new operator that is this at symbol. I'll call it at. But we don't use that in our arithmetic, do we? So, but we know the following properties for any x and y. Okay, so x at 0 is x. Okay, so any number at 0 is x. Alright, x at y is y at x. Okay, so we have a commutative relationship here between with the at operator. Okay, and this would be an identity here. So 0 is an at identity, just like 1 is a multiplicative identity, right? So in this case, 0 is the at identity. Okay, and then we're also given this thing that says that x plus 1 at y is equal to x at y plus 1. Okay, and then we're asked, what is 12 at 5? Okay, well, let's see what we can do here. Well, we're working with the numbers 12 and 5, so I'm going to start by saying, well, I know 12 at 0 would be equal to 12, right? And with this operator, or with this property here, this commutative property, I also know that 0 at 12 is also equal to 12, right? Because it's commutative, right? So 0 at 12 is equal to 12 at 0, which is equal to 12, okay? And then we know that x plus 1 at y is equal to x at y plus y plus 1. All right, so let's see what we can do with that. Now that we have these two things here, you can probably see what we can do here. If I say, so if I know 0 at 12 is 12, then I can say 0 plus 1, okay, I'm using x, or using 0 in place of x, at 12 is equal to, okay, so I've got 0 at 12 plus 12 plus 1. Alright, so all I'm doing here is I'm saying, okay, x is 0, y is 12, and everywhere that I see x, I'm going to put a 0. So I'll put a 0 there, a 0 there, right, here and here, right? Right, that's x. And then anywhere I see y, I'm going to put a 12. So there's 12 there, and 12 and 12, right? Okay, so I'm just using x equals 0, y equals 12, and then just replacing x and y. Alright, so this is saying here that 1 at 12 is equal to 0 at 12, which is 12, right? Plus 12 plus 1, so that's 24 plus 1, which is 25. Okay, so we know 0 at 12 is 12, 1 at 12 is 25. Alright, well, let's do that again, because we're getting closer. We want to get up to 5. Well, I should probably say too here that if we're trying to find 12 at 5, that's the same thing as 5 at 12 by this commutative property. Alright, this is commutative, and this is the identity. Okay. Alright, so let's keep going with this. I can now say that this is x and this is y, and plug it into this third property here. And so I'll say 1 plus 1 at 12 is equal to 1 at 12 plus 12 plus 1, right? Again, I'm just substituting for x and y in this property here. So, but this time I used 1 was x and 12 was y. Alright, so now we have 2 at 12 is equal to 1 at 12, which is 25, plus another 12, which is 37, 38. So it looks like 38. 2 at 12 is 38. Is that right? Alright. So now let's do it again. So I can say 2 plus 1 at 12 is equal to 2 at 12 plus 12 plus 1, right? So what does that tell me? That tells me that 3 at 12 is equal to 38 plus 13, which is, equal to what, 51? Right? 11 plus 40, yep, 51. So, let's do that again. Because then we'll get 3 plus 1 at 12 is equal to 3 at 12, right? Plus 12 plus 1, right? So, now we know 3 at 12 is 51. So, 51 plus 13 equals what? 64. Right? So that's 4 at 12. Alright, we're almost there. So, let's keep going. 4 plus 1 at 12 is equal to 4 at 12 plus 12 plus 1. And so we end up with 64 plus 13, which is 77, is equal to 5 at 12. And we know 5 at 12 is the same as 12 at 5, which is, again, just 77. Alright? So there you go. There's our answer. 77 is 5 at 12, or 12 at 5. Alright?